Halogens are the 17th group on the periodic table. The group consists of 5 elements: fluorine, chlorine, bromine, iodine, and acetine. All elements are highly reactive and toxic. All 5 elements have 7 valence electrons in their outer orbital, and 1 is missing for all elements to become stable. Halogens are reactive due to the -1 valence in their outermost shell, which creates the need to gain or create a covalent bond with another electron. Similarities of halogens also include nonmetal elements, high nuclear charge, which results in high electronegativity, making them reactive also. The higher up in the group, the more reactive each element is. Fluorine is the most reactive, and least reactive is iodine. The high reactivity is due to that the element's outer shells are unstable and aim to steal an electron from any element to become stable and to fulfill the octet rule. All the elements are desperate for an electron from any element it comes into contact with. Fluorine is so reactive that it even attacks glass and causes water to burst into flames. The atomic structure becomes larger as you go down the group due to additional added electron shells. The smallest atom of the halogens is the fluorine atom. This is due to there only being 2 electron shells. Halogens are lightweight since they are gaseous elements. When viewing their atomic shells, they all have 7 electrons and need 1 more to form a full octet in order to be stable. The boiling point of the elements increases down the column. However, they are quite low compared to other groups in the periodic table as they are lightweight. Although, due to the increase in atomic mass and in atom size, the molecules become larger, therefore more electrons, which results in attractions. As the elements and their attractions increase, the amount of heat needed to turn them into another state of matter is needed. Electronegativity is the ability to attract electrons towards itself with a covalent bond, which is a pair of electrons that are shared between 2 atoms. It is dependent upon the attraction between electrons that are bonding in the outer shell and the nucleus. The halogen atoms increase in size, therefore the bonding pairs become further away, so the attraction weakens. Therefore, as you go down the group, the elements become less electronegative. The positioning of the halogen group is due to electronic configurations. The halogen group have high electronegativity as they only need 1 more electron to satisfy the full octet. However, from this, it indicates that they are still not stable elements, which distinguishes them from the noble gases. They are also positioned on the right because they are likely to be anions when performing covalent and ionic bonding. Since they gain that extra electron in order to make the entire atom, this is more electrons, which means more negative charges are produced. In order for an atom to have high boiling and melting points, they need to have large atomic mass, since more energy requires to break the atomic bonds, whereas halogens are lightweight and require fewer energy to break their bonds. Hence, they are positioned on the right-hand side of the periodic table. Fluorine and all the other elements in the halogen group have 7 valences in their outer orbital. The structure of the atoms increases as more electron shells are added to each element down the group. The structure of the halogens is particular and relates to the properties of the group. Down the column, the electron shells on each element increase. The nucleus is a positive charge and the electrons are negative, creating an attraction between the electrons and the nucleus. Fluorine is the most reactive element due to there only being 2 electron shells, and the attraction is very strong between the nucleus and the electrons as the distance from the furthest electron is short. When referring to reactivity, the atomic structure is the reasoning behind the high reactive nature of the elements. The 7 valence in all the elements' outer orbital is also another structural principle that leads to the elements to be reactive, as the elements crave 1 electron from any element to balance their outer shell. The alkali metals are the first group on the periodic table and have similar properties of the halogens. Alkali metals have 1+ electron charge, whereas the halogens have -1. The alkali metals have 1 too many electrons in their outer orbital, whereas halogens have 1 less. Alkali metals need to distribute 1 electron from their outer shell to be a stable element. Therefore, the alkali metals prefer to bond with the halogens and vice versa, as they both benefit from the combination due to both elements becoming stable after combining with one another. Due to this scenario, both groups are highly reactive as they need to distribute or gain an electron. This is considered the octet rule, that there is 8 electrons in the outer shell for the element to become balanced.